interstellar medium and star formation. Star formation and interstellar medium are intricately related. The interplay between the two is central to the fundamental issues of evolution of universe at one end and formation of planetary system at other, thus influencing virtually every theoretical and observational subfield. While stellar astrophysics has entered a new era of exploration, a comprehensive picture of star formation process and diverse condition in the ISM is still elusive. The formation mechanism of two ends of mass regime, that is the high mass stars and self-gravitating substellar mass objects, remain poorly understood both theoretically and observationally. In a broader sense, the presence of dense molecular phase in the ISM is an important ingredient for star formation. On the other hand, the physical state of different phases of ISM, including the dense molecular phase, is governed by past and ongoing stellar activities. It is interesting to note that the metal enrichment of ISM depends on integrated star formation history of the host galaxy. Thus, detailed studies of star formation and physical conditions prevailing in different phases of ISM are complementary to one another. There are a number of outstanding questions in the field that motivate researchers around the globe. A few are mentioned here. What is detailed astrochemistry? The origin of cosmic rays and their influence on physical conditions in the ISM. Stars are born within molecular clouds, a process that begins almost as soon as narrow molecular gas has itself formed. This fundamental process of formation of molecular clouds, which is the rate determining step for star formation itself, is yet to be observed. What are the mechanisms that led to formation of giant molecular clouds? What is the contribution or interplay of turbulence, magnetic field and gravity in formation of protostars? The effect of magnetic field on star formation rate and stellar initial mass function is still an open question. Among the other pertinent questions in the field of star formation that are yet to be fully answered are the role of jet outflows in the star formation process and viable launching mechanisms of these. Once the cloud starts collapsing due to conservation of angular momentum, they form accretion disks which have now been observationally confirmed to form as early as protostar phase. Questions remain on exactly how the angular momentum transport occurs, which lets the infalling gas relinquish its angular momentum to accrete onto protostar. What are the roles played by the outflows, magnetic fields, and various turbulence in the accretion disk? What is detailed structure of innermost regions of disk in the accretion episodic for all n stars like EXORs or only few perturbed systems? The key to understanding this active phase of protoplanetary disk is via understanding and modeling the complex light curves from YSOs. With the data from modern multi-report photometric and spectroscopic time domain astronomy surveys, it will be possible to understand the complex physics of accretion in stellar objects. What are the processes involved in filtering the chemistry driving UV radiation incident on the disk that alter the composition of forming planetary system? Understanding various feedback manifestations and mechanisms of high mass stars in an upcoming field. The strong UV radiation field of high mass stars affect the ISM both physically, chemically and mechanically. Easily detectable in high redshift galaxies, the UV irradiated gas is an important tool for understanding the history of formation and evolution of structure in the universe as well. Another realm of feedback from massive interstellar objects involves a protostellar jet interaction with the ISM leading to particle acceleration and non-thermal radiation. This opens up a new window to investigate shock physics in stellar systems and contribution to production of galactic cosmic rays. The central molecular zone provides an ideal laboratory for probing star formation process under extreme conditions. The lack of present-day star formation in the CMZ is surprising given its dense gas reservoir. Despite various proposed theoretical models, the star formation in the CMZ is not well characterized observation. When we consider the IMF, a number of interesting unresolved aspects remain. Robust observational finding is its near universality in the Milky Way and neighboring galaxies. But is it possible to reconcile extragalactic IMF variations with universal Milky Way IMF? How does it depend on environment or meteoricity? How does it behave in extreme environments like